ನೆನೆ ಬಂದಿರಲಿಲ್ಲ. ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರ? ಓಕೆ. Good morning. Yesterday we were discussing about the basics of chemistry. We have discussed about electricity, gravity, etc. topics yesterday. Today we'll recall the last topic, acids and bases, and we'll continue with it. Acids and bases. Can you give any example for acid? Any acid which you can name. Acid present in lemon. Citric acid. Right. Likewise, hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, phosphoric acid. Various acids are there. Tartaric acid, citric acid, formic acid, methanoic acid. Right. The pH scale, potential of hydrogen or potence of hydrogen scale, based on the concentration of hydrogen ions, based on the concentration of H, hydrogen ions, we have pH scale, potence of hydrogen, potential of hydrogen scale. Okay. The pH scale range is 0 to 14. Range of the scale 0 to 14. Here 7 is the neutral value. 7 neutral value. 0 to 7 we have acids. 7 to 14 we have bases. 7 to 14 we have bases. Okay. 0 to 7 acids. 7 to 14 bases we have. Acid, if the pH value is nearly 0, it will be strong acid. Less than 7, weak acid. Just above 7, weak base. Nearly 14, strong base. Okay. Acids are sour in taste, huli, sour in taste acids. Bases are base taste, bitter. Bases are bitter in taste. Okay. But we cannot test each and every object, right? For example, sulfuric acid we cannot test. Hydrochloric acid we cannot test. That's why we have indicators. Indicators will change color and indicate whether the tested object is or material is either acid or base. It will indicate by changing color. We have pH scale, potence of hydrogen scale, pH scale 0 to 14. 7 is neutral. Nearly 0 pH value, battery, the acid present in the battery. Which acid? H2SO4, sulfuric acid. Lead acid battery, the normal big batteries we use at our home in the UPS, right? Acid battery, that is lead acid battery. The acid present in that battery is sulfuric acid, H2SO4, strong acid. Then in our stomach, which acid do we have? Hydrochloric acid, HCl we have in our stomach. Hydrochloric acid, nearly 1 pH value. In lemon we have citric acid. In vinegar, we have acetic acid. In tomato, we have oxalic acid. Oxalic acid. In coffee, we have chlorogenic acid. Chlorogenic. In tea, we have tannic acid. The caffeine content is not acid. Caffeine is a neurostimulator. It will stimulate and it will create the active sense of mind, right? That is caffeine. Then soft drinks, acidic or basic? Pepsi, Coke, Thumbs Up, etc. Acidic. Soft drinks are also acidic. In soft drinks, carbonic acid is present. Carbonic acid. Carbonic acid. In apple, we have malic acid. Malic acid. In we'll discuss. In milk, slightly acidic. Which acid is present in milk? Which sugar is present in milk? Carbohydrate. See, if a person who does not drink milk or milk-based, if he doesn't consume milk-based products, he is generally called as lactose intolerant. Right? Lactose intolerant means he does not drink milk. If he drinks milk, some sort of allergic reaction happens in him. Lactose intolerant. Have you seen anybody who doesn't drink milk? There are few people who are lactose intolerant. The sugar present in milk is lactose. The acid present in milk is lactic acid. Majorly when compared to curd and milk, in curd more amount of lactic acid is present. In sour milk more amount of lactic acid is present. The normal milk is slightly acidic, just below 7 the pH value is. Exactly 7 the pH value. Pure water. Pure water means drinking water. No, drinking water is fresh water. Pure water is distilled water. Distilled water. Only H2O molecules are present. Pure water pH value 7. Then drinking water pH value is how much? 6.5 to change it to 8.5. The range is little high. 6.5 to 8.5. Drinking water pH value 6.5 to 8.5. Okay. Then blood slightly basic 7.35 to 7.45. Then stomach tablet means the antacid tablets. If you get acidity, you have some tablets like Gelusil, Digene, etc. Those tablets are antacid, means anti against acid, that are bases. Antacids are nothing but bases, right? For example, milk of magnesia, magnesium hydroxide base, magnesium hydroxide. Then baking soda, sodium hydrogen carbonate or sodium bicarbonate. Baking soda, sodium bicarbonate. Ammonia solution. So, if we use sodium hydroxide in manufacturing soap, then we will get washing soap, dishwashing, cloth washing soap. If we use potassium hydroxide to manufacture soap, we will get bathing soap. Bathing soap by potassium hydroxide, washing soap by sodium hydroxide. Sodium hydroxide is also called as caustic soda. Sodium hydroxide is also called as common name. Common name of sodium hydroxide, what? Caustic soda. Then potassium hydroxide, caustic potash. Caustic potash, potassium hydroxide. In drain cleaner, wind cleaner, we use base. Those are also bases, right? Let us know some important acids. Acids can be classified as strong acids and weak acids. Strong acid means nearly 0 pH value. Strong acids, the example are hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, etc. Weak acids are the acids are normally present in fruits and vegetables like tartaric acid, malic acid, oxalic acid, citric acid. These are weak acids. Weak acid. If you put some lemon on your skin, citric acid, it will cause little irritation but not complete burning. If you put hydrochloric sulfuric acid, it will cause burning, right? More acidic, strong acid, hydrochloric, sulfuric, etc. acids. These are less acidic, which citric, oxalic, etc. Right? These are weak acids. The important acids which we come across during our day-to-day life, the acids which we come across in our day-to-day life. First one, hydrochloric. Before that, sulfuric acid, the acid present in battery. Sulfuric acid. Hydrochloric acid, the acid present inside our stomach. Gastric juice, the gastric juice, that is hydrochloric acid, the acid present inside our stomach. Okay. Then we have citric acid present in, where does it present? Citric acid, citrus fruits, lemon and other citrus fruits, lemon, orange, etc. Right? Citrus fruits, citric acid. Then we have oxalic acid present in tomato, spinach, etc. See how kidney stone is formed. If you eat tomato, you will get kidney stone. Actually, if you don't drink required amount of water continuously, regularly, what will happen? The waste will not be excreted properly. It will be accumulated there itself. Let's say, for example, in your kitchen sink, if you don't pour suitable amount of water and clean it, the waste will be accumulated there itself, layer by layer, forming scale-like structure, right? Scales. Likewise, in our intestine, in our kidney, what will happen? The waste will be accumulated there itself. It is not moving out. Then it will form a hard crystal-like structures that we call as kidney stone. The chemical name of kidney stone is kidney stone. Chemical name, calcium oxalate. Calcium oxalate, kidney stone. Calcium oxalate, chemical name of kidney stone. That is the reason doctor asks you to avoid oxalic acid rich foods. Oxalic acid rich foods, right? Then in vinegar, which acid is present? Vinegar. To the gobi Manchurian, they will add a transparent liquid, vinegar. Acetic acid. Apple. Malic acid. Tamarind. Huಣಸೆ ಹಣ್ಣು, tamarind. Grapes. Unripe mango. Unripe mango means it is not ripened yet. Unripe mango, the raw mango. Okay. Unripe mango, all these have tartaric acid. Tartaric acid. In one examination, listen, they have asked a question: why raw fruits are sour in taste when ripened fruits are sweet in taste? What is the reason? Generally it is there, right? For example, in the case of mango, raw mango is sour, very sour, but same, the ripened mango will be very sweet. The reason? Generally, if you think, what? Might be the reason. Say in your words. That's fine. Don't know. Animals can protect their babies by fighting back, right? If you try to catch a baby chicken, its mother will come and try to pick you, right? If you try to catch the baby dog, its mother will attack, at least bark, right? Likewise, the seed present inside that fruit is the baby of the tree, right? Seed is the baby, it's baby. It needs to protect that baby seeds. The tree needs to tell you, please don't pluck, right? But it cannot. That's why it is a defense mechanism. It is a defense mechanism where when the fruits are raw, the seed inside is still not yet developed to its fullest stage. It is underdeveloped. The seed is not developed yet. That is the reason for the seed to be developed properly. The fruit is raw and sour. When the seed is completely developed, it will be sweet, fragrant, colorful. That's why you can pluck it, have the fruit, and throw the seed. The seed will grow into a new plant tree, right? That is the mechanism. Defense mechanism, simple defense mechanism by the tree. Okay. Then in desert plants, in the desert, the plants usually bloom, flower during night time. What is the reason? They have asked in a examination. Generally, the desert plants bloom flower, they will flower during night time only, night time. For example, you might have you seen the Brahma Kamala flower? When it will bloom? Night time. You might have thought many a times, what a beautiful flower. If it would have bloomed in the morning, it would be better. We could have offered it to the god, etc. Right? But it blooms generally during night time. The reason that the plant is also even the dragon fruit plant, etc. Similar kind of plants. Those are desert plants. Desert plants. Cactus, let's say, desert plant. In the desert, during daytime, the temperature will be very high, right? Daytime temperature very high. The animals, rat, snake, etc., lizards, etc., they will be living inside a burrow hole during the daytime. They will not be active in the daytime. They will be active during the night time because the temperature is comparatively less. They can easily come out and find their prey. All the animals, insects are active during night time in the desert. That is the reason the flowers will bloom during night because pollination should happen, right? The insects, rat, etc., they will help in the pollination. That is a I mean, adaptation to that condition, adaptation for the desert condition, right? For pollination to happen, with the help of the nocturnal animals, desert plants bloom during night time, not during the daytime. That is the reason. Okay. Here, tartaric acid, tamarind, grape, unripe mango. Then ant bite, ant bite. Irritation it will cause, right? Ant bite, burning sensation it will cause. Ant bite, formic acid, formic acid. Then you might have experienced or you might have seen the itching leaves called nettle leaves, nettle leaves. Turke soppu kelidira, nettle leaves. If the leaf comes in contact with your skin, it will cause itching, severe itching, right? What's the solution to get rid of itching? What is the solution? How can you get rid of itching? Washing it off. That's it. With enormous amount of water or with soap. With soap, if you wash it off, it will go. The itching will reduce, right? There are so many small spike-like projection, pin-like projections present on the surface of that leaf. When it touches, it will inject methanoic acid into your skin. The itchy acid called methanoic acid. Methanoic acid is injected. Actually, formic acid, methanoic acid, both are one and the same. But when they have asked a question about ant bite, they have given formic acid. When they speak about nettle leaves, they generally give the answer as methanoic acid. Actually, both are the same. Formic methanoic acid. These are the important acids. Acids. Okay. Then bases. And one more thing. Which layer of our soil is more nutritious? Which layer of our soil is more nutritious? Means the top layer, layer below the top, layer below that, or the layer below that. Which layer will be having more nourishment? Soil. Top, below, first layer, below that, second layer, below that, third layer. Which will be having more nutrition? Take a guess. See, if you have observed few farmers, what they will do, if our farmland is little lower compared to other lands around us, we will get more amount of water during rain. They will think, that's why they will remove the soil and transport it to elsewhere. They will make a burrow, right? They will plant trees there. Will those trees grow well or not? They will not actually. What will happen? They will be malnourished. If you provide suitable amount of fertilizers, they will grow. Otherwise, they will not. Because very, very important. You might have written many essays in your school days regarding soil erosion, etc. Topsoil should be conserved, retained. Soil erosion should not happen, etc. You might have written, right? Topsoil is like gold. Very important. Topsoil. The maximum amount of nutrients are present in the topsoil itself, because leaves will fall off, plants, trees will fall off, animals will die, those bodies will decompose. The decomposed matter, the nourishment will be added to the topsoil, right? When you go below the topsoil, there will be only standard earth minerals, no organic matter, right? No important required nutrients are present. That's why topsoil is very important. Conserving topsoil is very important. Okay. Topsoil contains organic matter called humus. Topsoil contains humus. The acid present in the topsoil, the acid present in the topsoil is humic acid. Important, humic acid. It should be slightly acidic, not heavily acidic, slightly acidic. Humic acid is present, humic acid in the topsoil. Okay. Then we have bases. For example, antacid, or stomach tablet, we can say. Stomach tablet, antacid, milk of magnesia, milk of magnesia, magnesium hydroxide, milk of magnesia. It is having the texture, appearance just like the milk. That's why the name milk of magnesia, magnesium hydroxide. It's a milky kind of solution, right? It is a antacid. When you have severe acidity, gastric condition, you can have it. the syrup, glycerol digen syrup, that is milk of magnesia, antacid. Then lime water. Water. Lime water means, this is the problem. In one examination, in our KPSC examination, our KPSC, Karnataka Public Service Commission, is famous for the translation mistakes. Recently, the KS examination got squashed due to some issues, and they have conducted a preliminary examination twice. The reason, translation issues. So many translation mistakes from English to Kannada. For example, interference, a phenomena of light. Interference means when during the rainy season, water on the road, oil on the surface, oil seems like a rainbow, right? That is interference. Soap bubble feels like a rainbow kind of colored thing. That is interference. Interference in Kannada, it's called Vyatikarana. But they have given Hastakshepa. Hastakshepa, that means interfering, right? Interfering. That kind of mistakes they will do. Here also they have asked once, lime water. Lime water actually means, in Kannada they have given nimbe ನೀರಿನಲ್ಲಿ ಏನಿದೆ, nimbe ನೀರು. But actual lime water means sunna. Lemon is nimbe ಹಣ್ಣು. Lime means sunna. Lime water means sunnada ನೀರು. Okay, not the citric acid, normal juice, lemon juice. But in normal terms, we do say lime juice, right? But that is not the exact term to be used. That is lemon juice. This is lime water. Lime water means calcium hydroxide. Calcium hydroxide. Sunna. Calcium hydroxide. Lime. Then ammonia solution. Then we have window cleaner, etc. Ammonia solution. Baking soda. Baking soda. Sodium hydrogen carbonate or sodium bicarbonate. Baking soda bicarbonate. Sodium bicarbonate. Then we have washing soda. Washing soda. Na2CO3. What can we call this? Na2CO3. CO3, not Cl. Na2 means two molecules of sodium. CO3 means carbonate. This is simply sodium carbonate. That is sodium bicarbonate, baking soda. This is sodium carbonate. Sodium carbonate. Washing soda. Sodium carbonate. Sodium carbonate. Washing soda. Sodium carbonate. Okay. These are all the examples of bases. Base. The pH value of bases will be in the range of bases. Yes, 7 to 14. 0 to 14 is the pH scale. There 0 to 7 are acids, 7 to 14 are bases, right? Okay. Then the indicators. Indicators. What indicators will do? They will change the color. They will change the color. By changing color, they will indicate whether the sample you are testing is acidic or basic. If I test the water sample, should it be acid or base? What it should be? Drinking water, generally, normally. Drinking water pH range is 6.8 to 8.5, right? If it is 6.5, 6.6, 6.7, it will be acidic. If it is more than 7, it will be basic. But general consideration, drinking water should be alkaline. Alkaline means base. Base means 7 to 14 pH value, right? Here, see, Indicators, by changing color, they will indicate whether the tested sample is acid or base. The most famous indicator which we can use. First, we have natural indicators, which are available in the nature. Natural indicators. First one, litmus paper. Litmus paper. Even we can use litmus solution also. Litmus. Have you heard the name litmus paper? Dove soap advertisement, have you seen? Few years back, Dove soap used to give an advertisement where two white color soaps are placed. Two paper strips they took. One paper strip turned blue, one paper strip turned red. They told red color is not ours, blue color is ours. That is good for your skin. That is the litmus paper test. The paper changed its colors to red and blue. Red means acid, blue means base. Right? Litmus paper is produced by lichens or lichens. Have you heard the name lichens? Lichens. Above mango tree or coconut tree, white color patchy like structures. Have you seen? You might have seen, but you might have forgot. Lichens. This you have seen, right, on many trees. In Bangalore, it is less seen. Reason lich are lichens are natural indicators of air pollution. Natural indicators of what? Air pollution. Natural indicators of air pollution. Where pollution is more, they will not grow. Where pollution is less, they will grow. In Bangalore, the pollution is more, they will not grow, or the growth will be minimal. In rural areas or Western Ghats, the pollution is less, they will grow better there. Air pollution indicators, lichens, right? The two specifically, they are the indicators of sulfur dioxide pollution. Natural indicators of which pollution? Sulfur dioxide pollution. If sulfur dioxide pollution is more, then they will not grow there. By observing the growth, we can say if the pollution is more or less in that area. Lichens. Actually, these lichens are also used as a spice, masala padartha spice. In Bangalore, many normal provision stores, it's available. Next time when you go to buy any groceries, ask for kalluhu. It is called as kalluhu because it also grows on the rocks. On the rocks also it will grow, right? That's why the name kalluhu. Lichens. Generally, we don't use it as a masala spice, but in few regions they do use. That's what lichens. Litmus paper is produced. Litmus paper is produced by what? Lichens with acids, with bases. How the color changes? Let's see how the change in color will happen. Litmus paper will turn red with acids. Litmus paper will turn blue with bases. Litmus paper, even the litmus solution, liquid solution. Litmus solution is light purplish in color. Mauve, we say mauve color. MAUVE, mauve color. Litmus solution. But generally we don't use litmus solution because difficult to carry, etc. Paper is better, right? Easy to carry. Litmus paper we use. Most important indicator, litmus paper. Red with acid, blue with base. Distinct color change, we can simply say whether the tested object is acid or base. Okay. Then we have turmeric. We do have use turmeric at our home, right? Turmeric, arishina, we do use. It is a super natural indicator. Turmeric is normally in which color? Yellow color, right? Turmeric, it is yellow in color, yellow color, turmeric. With acid, there is no color change. With acid, no color change. Yellow color only will be there. With base, the color changes to bright red. Bright red with base. Do you know about the meteor formed crater lake of India? Do you know about meteor? Not the Royal Enfield meteor. Ah, the big rock meteor which comes shooting towards the planet, for example Earth. One find many years ago a meteor struck the surface of Earth near Maharashtra, in Maharashtra, and it formed a crater 2 kilometer diameter. Just imagine the diameter of the lake crater formed, crater Kuli formed, is 2 kilometers in diameter. The big lake, Lonar Lake, very important lake. Lonar Lake is formed by the meteor strike. In YouTube, it is present. You can check. Lonar Lake water. A person took, and he told that, see, generally the water bodies are contaminated these days. If we test any normal water sample, it might be slightly acidic due to contamination, pollution, etc. But the Lonar Lake sample is basic. That too, heavily alkaline, good to drink. He tested the alkaline nature of Lonar Lake water with the help of turmeric. He took a packet of turmeric. He just got a glass of Lonar water lake and he added turmeric to it and mixed. Turmeric is yellow in color. If the water is acid, means it should be yellow itself, no change in color. But the water is base, so it turns red. Magic. Turmeric turns into which color? Red color, bright red color, because it is base. The water is base. If this water is basic, it should be basic. If this water is basic, if I add turmeric to it, which color it should change to? Base, which color? Red color. If it is slightly acidic, it will remain yellow itself. If it is more basic, it will turn to red color. At your home, what are the basic products you have? Bases you have? You have baking soda. Baking soda you'll be having at home, right? That is base. You can create baking soda solution that will be nearly transparent. If you add turmeric, it should turn red. Baking soda solution with turmeric, it should turn red because that is base, right? Simple test which you can do at your home. For that, turmeric should be natural. It should not be mixed with any chemicals. Then only it will change the color properly. Okay. Turmeric we can use as an indicator. Then we have hibiscus flower petals. Hibiscus flower petals. Hibiscus daswala, you know, right? Daswala, hibiscus. China rose also they call. China rose. Hibiscus flower is available in which color? Different colors, so many colors. Red, pink, white, yellow, various colors it is available, right? Any color it might be. Take the flower petals and boil it in a glass of water. The solution which you will get will be in some color based on the color of the flower. Okay. If you add acid to it, if you add acid to it, the color changes to dark pink. Dark pink color called magenta. Magenta color it will change to magenta. Then if you add it to base, it will turn to green color. With the base green color with acid dark pink magenta color, you can use hibiscus flower petals as indicators, natural indicator. Then we have a red cabbage. Red cabbage indicator. Have you seen red cabbage? Cabbage means cabbage, ಎಲೆಕೋಸು. Cauliflower it's a ಹೂಕೋಸು, cabbage ಎಲೆಕೋಸು ಅಲ್ವಾ? Red cabbage exotic vegetable. It's purple in color, but it's called as red cabbage. Purplish in color, called red cabbage. This one, red cabbage. If you take juice of red cabbage, red cabbage juice, okay, that is used as an indicator. With acid, it turns red. With base, it turns green. With base, it turns green. With acid, it turns red. Natural indicator. Natural indicator. Then we have olfactory indicator. Olfactory indicators. Olfaction means smell. Olfactory indicator means by changing smell, they will indicate whether the tested object is acid or base. By changing smell. Olfactory indicator. As an olfactory indicator, we can use onion or vanilla. Both will give same results, onion or vanilla. Onion or vanilla. With acid, smell remains. Vanilla will be having pleasant, beautiful smell, right? Vanilla flavor. Onion, pungent smell, bad smell will be there, right? Onion juice, onion. Smell will remain if it is mixed with acid. If it is mixed with the base, if it is mixed with base, the smell vanishes. Smell vanishes. Smell will not be there. Smell vanishes. So we can use onion or vanilla as indicators. Now, olfactory indicators. Then we have synthetic indicators. Synthetic indicators. First we have phenolphthalein. Phenolphthalein. Then we have methyl orange. Methyl orange as indicators. Phenolphthalein. You might have done this experiment in school or college. You both are from commerce background, you might have done. See, in PUC there is an experiment. Burette, you know, right? The big tube with a tap here, then opening here, this beaker. Okay. From the burette, you are adding a solution to the container, beaker. Here, from pink color to colorless, the solution turns. You might have done this experiment, right? Beautiful color change you will observe. The beaker solution will be pink in color. You are adding acid to it, continuously stirring. At one point, when you add that last drop, the complete color change will happen. from pink to colorless, from pink to colorless. With the base, the color will be pink. With the base, the color will be pink. With acid, the color will be nothing, colorless. Colorless with acid, pink with the base, that is phenolphthalein. The indicator is phenolphthalein. Usually sodium hydroxide, potassium hydroxide, these kind of bases are added in the beaker, pink color. Then hydrochloric acid will be mixed to it. At one point of time, the solution will turn acidic. From pink to colorless change. Beautiful indicator, phenolphthalein. In methyl orange, with acid, the color changes to red. Acid, red. With base, the color changes to yellow. Base, yellow. Methyl orange indicator, methyl orange. With acid, it turns red. With base, it turns yellow. These are the indicators which change color. By changing color will indicate whether the tested object is acid or base. Okay, fine. Mhm. Atom. Atom means small particle. Smallest indivisible particle. Smallest indivisible. We cannot divide it any further. We cannot divide it any further. That is the smallest particle. Can we see any atom with our naked eye? No, it is still smaller, microscopic, nanoscopic. We cannot see. We cannot see any atom with our naked eye. We can see the element. By combination of many atoms, the element is formed. Can you name any element in our period? Do you know periodic table? Hmm? In our periodic table, we have 118 elements. 118 right now. 118 elements we have, starting from hydrogen to organesson, 118th element, OG, organesson. Okay, we have 118 elements. Hydrogen, helium, lithium, barium, etc., etc. We have elements, right? Indian scientist, philosopher, etc., named Kanada, he first told, he was eating some chapati, roti, etc. He made small pieces out of it. When you are free, if you get a leaf, what you will do? You will make small pieces. If you get a paper, what you will do? You will make small pieces. The one small piece which you cannot divide further, one small piece which you cannot divide further, that he called an atom. But that is not exactly the atom, but the definition is somewhat similar. The definition is smallest indivisible particle which we cannot divide further. Smallest indivisible particle. For example, if you have a piece of if you have a piece of carbon, pure carbon, piece of carbon, on piece of carbon you have, okay, it is made up of many carbon atoms, right? It is made up of many carbon atoms, many carbon atoms. Atom is the smallest particle of an element. In an element, all the atoms are of similar shape, similar size, similar properties, right? All the atoms of carbon element have similar shape, similar properties, right? Carbon. Likewise, hydrogen, helium, anything. All are same shape, size, and properties they have. This is called as element. This small particle is called as an atom. This is combination of same type of atoms form? By combining similar type of atoms, we get an element. That is called as element. Element. Okay. Then with a particular ratio, we combine. If we combine two or more, elements, we will get. For example, I have one carbon, two molecules of oxygen. This is a compound, right? This is a compound. Compound means by the combination of two or more elements. That's it. Similar type of atoms combine to form a element. Similar type of atoms combine to form an element. Different elements combine to form a compound. Example for compound. Any compound. Water, H2O, combination of hydrogen element, oxygen element, water. Then hydrochloric acid, hydrogen, chlorine. Salt, table salt, sodium, chlorine, compound, right? In the atom, say, in the element, the smallest particle is atom, right? In the element, smallest particle is atom. In the compound, the smallest particle which exhibits the property of the compound, the smallest particle which exhibits the property of the element is called as, see, for example, if you have a glass of water, okay? Water means H2O, right? H2O, water. H2O. Is this a compound or element? H2O? Compound. By the combination of hydrogen element and oxygen element. Compound. The smallest particle of water which can exist independently and which shows the properties of water is, see, H2O is there. If I separate a hydrogen atom, if I separate a monoxide atom, will it show the property of water? No, right? Hydrogen separate, oxygen separate, will it show the property of water? No. Hydrogen is a gas, oxygen a gas. Hydrogen fuel, oxygen helps in combustion, right? The smallest particle of a compound with independent existence is called as, for example, in this a liter of water, there are so many small particles of water. Combining, it forms much higher quantity of water. The smallest particles of water with independent existence, these are called as molecules. These are called as molecules. Listen, smallest particle of an element is atom. See, the smallest particle of this element is atom. Same, the smallest particle of this compound is, molecule. Small molecule of water, small molecule of carbon dioxide, small molecule of sodium chloride salt, likewise, molecule. These are the basic terms which we need to know, right? Basic terms. What is the structure of an atom? Structure of an atom, how it is? Atom consists of the subatomic particles called. Atom consists of what? Positively charged particle, proton. Neutral charged particle, neutron. Negative charged particle, electron. Proton, neutron, electron. It is having what? The atom. Positively charged particle, proton. Neutral charged particle, neutron. The proton and the neutron combines to form the center of the atom. The center of the atom consists of protons and neutrons. That is called as nucleus of the atom. Nucleus is nothing but center of the atom. Those two combinedly called as nucleons means the molecules present or the particles present inside the nucleus of the atom, proton and neutron. Around these proton and neutron, in the outer shell we have electrons. In the outer shell we have electrons. Different higher shells we have electrons. Electrons we have. Okay. This positively charged particle proton, positively charged particle proton discovered by Rutherford. Negatively charged particle electron discovered by J. J. Thomson. Then neutral charged particle neutron discovered by James Chadwick. Neutron. Rutherford, Thomson, Chadwick discovered proton, electron, neutron. Proton discovered by who? Rutherford. Electron discovered by Thomson. Neutron discovered by Chadwick. Proton, electron, neutron. Rutherford, Thomson, Chadwick. Right? Pen is equals to RTC. Atomic theory. Thomson made an experiment called vacuum discharge tube experiment or cathode ray discharge tube experiment to detect or to find or to discover the electron. Cathode ray discharge tube experiment. Not so important for you. Here see, father of atomic theory, father of atomic theory, John Dalton. John Dalton is called as John Dalton, father of atomic theory. Dalton. He says each and every particle in the universe is made up of atoms. That's true, right? Atoms. Same type of atoms combine to form element. That is also true. Same kind of atoms combine to form element. Okay, he told. Then he tells atom of an element cannot be converted into atom of another element. Atom of one element cannot be converted into atom of another element. For example, iron atom cannot be converted into gold atom. That's true, right? You cannot convert iron into gold. That's what he said. One element's atom cannot be converted into other element's atom. Then he says all the atoms of an element have same property, size, shape, etc. That is Dalton's postulates or Dalton's theory. That is atomic theory. Dalton's atomic theory. John Dalton. Then we have different shells around the positively charged particle, proton, neutral charged particle, neutrons. We have electrons in different shells, right? Electrons in different shells. The orbits called as K, L, right? K, L, M, N, etc. Orbits are there. Shell number 1, shell number 2, number 3, number 4, K, L, M, N, right? There is a formula. This model, which explains electrons are revolving around the nucleus of the atom in circular orbit, explained by Neil Bohr, Bohr, Bohr. He explained this model. Name? Neil Bohr. This is called as Bohr's atomic model. Bohr's atomic model, Neil Bohr's atomic model. That is nothing but electrons are revolving around the nucleus of the atom. That's it. Electrons are revolving in differentials. Bohr's atomic model. Electrons are revolving in different shells around the nucleus of an atom. Around the nucleus. That's it. Bohr's atomic model. He says, see, every shell has the ability to hold particular number of electrons, right? If the number of electrons are not proper, means if first shell has the ability to hold 2 electrons, for example, that's true actually, 2 electrons. If there is only 1 electron, means that electron present in the outer shell is also called as the electron present in the outer shell is called as valence electron. Electron present in the outer shell called valence electron. Valence electron. See here, valence electron. Valence electron. These valency electrons participate during the time of chemical reaction. When chemical reaction happens, the electrons will participate. Contribution. Either donation or receiving of electrons will happen. Few will lose electrons, few will gain electrons. That thing will happen. That thing will happen in the outer shell, in the valence shell, valence electrons. Valence electrons participate in chemical reaction. Valence electrons, they participate in the chemical reaction. See, if in one atom free electrons are present in the first shell, in another atom free electrons are present in the third shell. First shell, one free electron. Third shell, one free electron. Which will be having more energy, means the atom which is having free electron in the higher shell will be having more energy. In the outer shell, if it is having more free electrons, then it will be having more energy. Very important. If the electron is in the outer shell, it will be having more energy when compared to nearby shells. If free electron is present in the outer shell, it will be having more energy. The formula is formula 2n square. Simple formula 2n square. Let's say n is equals to 1. What we will get? 2. 2 into 1 square, that is 2. In the first shell, we have 2 electrons. N is equals to 2 means what we will get? 2 square 4. 4 2s are 8. In the second shell, we have 8 free electrons. Then n is equals to 3 means 3 3s are 9. 9 2s are 18. In the third shell, we have 18 free electrons. Likewise, any number of shell, let them give. We can easily calculate how many number of electrons it can hold, the maximum number of electrons which it can hold. Okay. The capacity of first shell, 2 electrons. The capacity of second shell, 8 electrons. Likewise. Okay. If the shell is completely filled, it will not actively participate in the chemical reaction. If the shell is vacant, or if it has the ability to donate electrons or receive electrons, then only chemical reaction will happen, right? Free electron should be there, valence electron should be there for chemical reaction to happen, right? 1H1. Which atom is this? Which element is this? H, hydrogen. 6C12. This is carbon. 17Cl35. This is chlorine. 92, 235. This is uranium. Right? Here, the left hand bottom corner number we have 1, 6, 17, 92, etc. are there, right? Atomic number. Atomic number. Atomic number. Atomic number is denoted by capital letter Z. Atomic number, capital letter Z. Atomic number, capital letter Z. That is nothing but, atomic number is nothing but total number of protons. Total number of protons present in that atom. Total number of protons. Atomic number means, if the number of proton is 1, atomic number will be 1. If the number of protons are 6, atomic number 6. Likewise, see, who discovered periodic table? Mendeleev. Mendeleev discovered periodic table. When he discovered periodic table, he arranged the elements in the increasing order of atomic mass. Atomic mass, lower to higher. He arranged which the modern periodic table. Atoms are arranged in increasing order of atomic number. Atomic number smaller to bigger, left to right, left to right, left to right. Likewise arranged. Okay. The reason is that each and every element's atomic number is unique. It's unique. Atomic number 1 means it's hydrogen itself. No other element can have that number. In your school, your roll number would be unique, right? No other person can have the same roll number in your class. It's a unique number. Likewise, here atomic number is unique. 1 means hydrogen. 6 means carbon. 8 means oxygen. Likewise, 7 means nitrogen. Likewise. Okay. Atomic number is unique. Atomic number means total number of protons. Total number of proton. Atomic number means. Then mass number is indicated by capital letter A. Mass number indicated by capital letter A. Atomic mass number. Atomic mass number indicated by capital letter A. Mass number means total number of protons plus neutrons. Total number of protons plus neutrons. That is mass number. Mass number. Atomic number, total number of proton. Mass number, total number of proton plus neutron. Mass number. Right? In hydrogen, number of protons is 1. Atomic number 1, number of proton 1. Number of proton plus neutron is mass number. Number of proton plus neutron is mass number. Right? Proton plus neutron. Proton plus neutron. Atomic number means total number of proton. Total number of proton. Now tell me, how many protons are there in hydrogen? 1. How many neutrons are there in hydrogen? 1 plus 1 means it should be 2, right? Then 0. 1 plus 0. Then how many protons are there in Carbon, number of proton, 6. The number of neutrons will be 6. 6 plus 6, 12. Here number of proton, 17. Number of neutron, 17 plus 17, 34 plus 1, 18. 18, 35. Here number of protons will be 92. Number of neutrons will be 143. Number of neutron, total 235. Atomic number, total number of proton, mass number, yes, or proton plus neutron. Otherwise, atomic number plus neutron is also correct. Okay. Number of neutrons can be calculated by mass number minus atomic number. Correct, right? Mass number minus atomic number, we will get number of neutrons. 235 minus 92, 143. 12 minus 6, 6. 35 minus 4, 17, 18. We will get number of neutrons we can calculate. Fine. See. Isotope, isobar, isotone. Iso means similar, same. Iso means what? Similar, same. Iso means. Okay. Have you anywhere heard the name isobar? Anywhere? Have you heard the name isobar? Isobar. When you see the geographical map of the earth, there will be lines telling 1 bar, 2 bar, 3 bar pressure lines. Isobar means similar pressure, same pressure. In geography, isobar means places having same atmospheric pressure. Places having same atmospheric pressure. Those are connected with a line called isobaric line. Isobaric line. In geography, isobar means same pressure. In chemistry, isobar means that's completely different. Okay, we'll discuss. Isotope means in an atom, what is unique? Atomic number or mass number? In any element, which number is unique, which cannot be changed at all? Atomic number is unique, right? For example, hydrogen means atomic number 1, helium means atomic number 2, lithium means 3, carbon means 6. That is unique, which we cannot change. Here, see, isotope means same atomic number, different mass number, 1H1, 1H2, 1H3. These are isotopes. Isotope of hydrogen, heavier isotope of hydrogen. Atomic number is same, mass number is more. These type of elements are called as isotopes. See what happens here. How many protons are there? 1. Everywhere 1, right? Everywhere only 1 proton. Atomic number 1, 1, 1. It should be 1 for hydrogen. It cannot change. Mass number, it is changing. Here, 1 plus 0, 1 proton, 0 neutron. Here, 1 proton, 1 neutron, correct? 2, that's why. Here, 1 proton, 2 neutron. These are called as heavier isotopes of hydrogen. This 1H1 is called as procium. This 1H2 is called as deuterium. Dew means 2, deuterium. This 1H3 is called as tritium. 3. Deuterium and tritium participates in nuclear fusion reaction. Nuclear fusion reaction. Okay, the heavier isotopes of hydrogen. In our sun, fusion reaction is happening. Sun and stars. There, this heavier isotopes will participate, heavier isotopes of hydrogen. 1H2 is deuterium, right? 1H2O, 1H2, 2O means deuterium oxide. Deuterium oxide means heavy water, deuterium oxide. That is used as a moderator in a nuclear reactor. Moderator in nuclear reactor, heavy water. Okay. Produced from the heavier isotope of hydrogen. Okay. Then one more thing. Examples of 6C12, this is carbon, right? 6C13, 6C14, etc. are the isotopes of carbon. Have you anywhere heard the name C14 method? Carbon dating method. Have you heard carbon dating method? Carbon dating method is a method to find the age of a fossil. Fossil, fossil, padayulike, fossil, ancient product, material, anything, fossil. To find the age of that fossil, how many years back this rice sample, etc., or recently recently means many years back in Hallur, they found ragi present inside a pot. The age of that ragi can be detected with the help of C14, carbon 14. This method is called as C14 method. C14 method or carbon dating method. Carbon dating carbon dating method. Heavier isotope of carbon C14 is used to detect the age of fossils. To detect the age of fossils. Carbon dating method. Carbon dating method. C14 method. Then we have isobars. Isobars. Isobar means same what? Mass number. Same mass number and different elements but same mass number. Different elements with same mass number are called as isobars. See, in the same element atomic number cannot change, right? Because atomic number is the unique feature. That's why isobar, different elements, isobars. 17 chlorine 40, 18 argon 40, 19 potassium 40, 20 calcium 40. Here the atomic number is different because elements are different. Mass number same, right? Everywhere the mass number is same. These are called as isobars. Atomic mass number is same. These are called as isobars. Similar mass number, isobar. Similar mass number, they have isobar. Then we have isotone. Isotone, only number of neutrons are same. Only number of neutrons are same. Isotone. Atomic number is also different. Mass number is also different. Only number of neutrons are same. Isotone. 16 16 sulfur 36, 17 chlorine 37, 18 argon 38, 19 potassium 39, 20 calcium 40. Here atomic numbers are different: 16, 17, 18, 19, 20. Different elements: sulfur, chlorine, argon, potassium, calcium. Different mass number: 36, 37, 38, 39, 40. Right? What is same? Only number of neutrons. Here, number of protons and neutrons. Number of proton and neutron. Mass number means proton plus neutron, right? Mass number means proton plus neutron. Tell me how many number of protons are there here? 16 proton plus 20 neutron. 20 plus 16, 36. 17 plus 20, 37. 18 plus 20, 38. 19 plus 20, 39. 20 plus 20, 40. In all these cases, number of neutron is how much? 20. Different elements with same number of neutrons are called as isotones. Different elements with same number of neutrons. That's it. Same atomic number, different mass number called as isotope. Isotope, right? Same mass number, different elements called as isobar. Different element, different atomic number, different mass number, only number of neutrons are same. Isotone. Neutrons are same. Isotone, N isotone. What do we call it as? 3 bar, right? Bar will be in the top bar, right? Likewise, the top atomic mass number are same in isobar. Atomic mass numbers are same in isobar. Isotope, we should know. Atomic numbers are same. That's it. Then there is a special concept called mole concept. Mole concept. See, in a substance, there are so many molecules present, right? So many molecules. Molecule means smallest indivisible particle with independent existence of a compound. Smallest particle of a compound is molecule, right? Smallest compound of this water, smallest element of this, smallest particle of this compound water is H2O molecule, one small H2O molecule, right? Many molecules combine to form a compound. Mole concept means how many molecules are present. To calculate that, there is a concept. For example, we have dozen concept, right? Dozen concept. One dozen means how much? 12. If you have a bunch of banana, you will be saying there are 3 dozens of banana present here. If you have trace of egg, you will be saying 5 dozens of eggs are there, right? Dozen concept means there is a standard number. 1 dozen means 12. Likewise, in the mole concept, there is a standard number. 1 mole means, likewise, 1 mole means 6.023 into 10 power 23. Will the number 12 have any units? In dozen concept, the number 12, does it have any units? It is just a number 12, no units like kg, gram, etc. There are no units, right? Likewise, this is just a number, no units. 1 mole is equals to 6.023 into 10 power 23. This number is called as Avogadro's number. This number is called as Avogadro's number. Avogadro's number. Right? Let's see our periodic table. Just observe. It's in different color. Different elements have different properties. Metals, non-metals, then metalloids, etc. That's why the different color. Here, see the grayish color. The grayish color ends here, ends with polonium, grayish color. But here they haven't considered polonium, they have considered astatine. There is some ambiguity. Few countries, few scientists consider few elements under some group, few consider it under some other group. So let's consider the standard periodic table. Standard periodic table. This is good actually. It's visible, right? Is this visible? At least the letters. Yes or no? No. Letter? That's enough. No need of the names written below. Okay. You can differentiate by seeing the colors. Periodic table is a table. Why do you make any table? Table for your attendance. Table for income expenditure. Table for debit credit. There are varieties of tables, right? Your attendance table will be having your roll number, name, date, present, absent, etc. details. Likewise, the periodic table will be having the elements which we know, which we have discovered, which we have developed, right? How many periodic table elements are the elements which we know right now till date? How many elements are there in the periodic table? 118, 1118, 118, 118 elements we know right now, as of now. The number might increase later. Might, if there is any new discovery of new element, the number might increase. Right now it is 118, 118 elements in the periodic table. How the elements are arranged? The elements are arranged from left to right, left to right, left to right in the increasing order of atomic number. Atomic number. Atomic number means total number of what? Protons. Atomic number symbol is capital letter Z, right? Atomic number of this hydrogen is 1. Atomic number of this helium is 2. The first row. First row only hydrogen and helium are there. From the second row, lithium 3, beryllium 4, boron 5, carbon 6. See, carbon 6. The nitrogen 7, oxygen 8, fluorine 9, neon 10. Likewise, from left to right, sodium 11, magnesium 10. Likewise, we have how many elements? 118 elements, right? The 118th element is present here. According to the table, it should be present here, right? But there is a catch here. These two rows are taken out from here. 57 to 71, 89 to 103, the red, the green, lanthanoids and actinoids. These elements does not fit here in the main table. That's why they have created a separate two rows for these two. rows of elements. Lanthanoids and actinoids separate. That's why the last element is here. 1/18th element, OG, organesson, organesson, the 1/18th element, right? How many periods and rows are there in the periodic table? Periodic table is arranged in horizontal rows, then vertical, then vertical columns. The horizontal rows are called as periods. Horizontal rows are called as periods. Okay. Vertical columns are called as groups. Periodic table consists of periods and groups. Horizontal periods, vertical groups, right? How many periods and how many groups are there? See, count. Period 1, 2, 3, 4, 5, 6, 7. That's it. This is separate, taken from here, right? How many periods are there? 7. In the periodic table, we have 7 periods or 7 rows. Standard, it will not change. How many groups are there? 1, 2, 3, 4, 5, 6, 7. 18 groups are there. In the periodic table, we have 18 groups. 7 rows, 18 groups in the periodic table. Based on what the periods are made? Periods are based on, see, the horizontal rows, periods, how many? 7 in number, are based on the number of shells. Based on the number of shells means the first period only 1 shell, the second period 2 shells, the third period 3 shells, like this. Fourth 4 shell. Total maximum how many shells? 7 shells. Till 7 shells it is having. In one shell, how many number of electrons can be placed? That can be calculated with the formula 2n square. First orbit 2 electrons, second orbit 8, third 18. Likewise we can calculate. Okay. Periods are based on what? Number of shells. Periods are based on number of shells. Then the vertical columns are called as what? Groups. How many groups are there in the periodic table? 18 groups are there in the periodic table. These are based on what? Groups. Same number of valence electrons. What? Same number of valence electron. Valence electron means electron present in the outer shell. The shell might be first, second, third, fourth. That doesn't matter. What matters? How many numbers of valence electrons are there? See here, for example, the yellow color, group 1A. Group 1A. Alkali metals. Alkali metal. Alkali means base. Alkali metals, group 1A. They will be having same number of free electrons. Let's say 2 free electrons. Okay. Here, lithium will be having how many shell? 2. Sodium will be having how many shell? 3. In the second shell, lithium will be having 2 electrons. Sodium will be having in the third shell 2 free electrons. Likewise, all will be having same number of valence electrons. Groups are made based on number of valence electrons. Number of valence electrons. The two same number of valence electrons should be there. Same number of valence electrons. In each and every group, same number of valence electrons should be there. Based on that, groups are made. How many groups are there? 18. How many shells are there? 7. That means based on the number of shells, periods are made. Periods are made, right? Very much important. See, right now, just by observing, tell me, if I go from top to bottom, top to bottom, atomic size of the atom, will it increase or decrease? Why? Number of shells are more, right? Here only one shell, here two shell, three shell, four shell, right? That's why the size will increase. From top to bottom, from top to bottom, atomic radius or atomic size, it will increase. It will increase because the number of shells are more. One, two, three, like this. The number of shells will increase. Now, if I go left to right in a period, left to right in a period, atomic size, will it increase or decrease? Right now, we cannot tell exactly. See, in the same period, the number of shells will be same, right? For sodium, 3 shell, magnesium, 3 shell, aluminium, silicon, phosphorus, sulfur, chlorine, argon, each and every element present in that row will be having how many shells? 3. Only 3 shells. From left to right, what will happen? See, 1, 2, 3 shell, 1, 2, 3 shell, right? From one column to other column, what will change? Column group. Groups are based on what? Number of free electrons, valence electrons, right? Here, for example, one free electron is present. Here, for example, two free electrons are present. Here, for example, three free electrons are present. That will change. Number of free electrons, valence electrons will change. From left to right, the number of valence electrons will increase. The number of valence electrons increase. If that increase, what will happen? The center of the atom, nucleus of the atom will be having, center of the atom is made up of what? Protons and neutrons. Positively charged proton, neutral charged neutron. The center will be having proton. The outer shells will be having electrons. If the number of electrons increase, what will happen? It will shrink because of the attraction between protons and electrons. Oppositely charged, right? That's why they will shrink. So from left to right, the atomic size will shrink. Size will decrease. From left to right, atomic size will decrease. Reason, number of shells will be same in a period, but the number of valence electron will increase. The number of valence electron increases from left to right, it will create a force of attraction between the proton. So the atomic size will decrease, shrink. That's it. Top to bottom increase, left to right decrease. That's it. Atomic size. In the periodic table, 75% of the elements are metals. 75% elements are metals. Remaining few percent only non-metals. So majority of the elements which we know, which we have, are metals. Majority of the elements are metals. Hydrogen, non-metal. Special property it is having. Hydrogen, non-metal. Okay. Then under hydrogen we have yellow color group, alkali metal, alkali metal. Then orange color group, alkali earth metal. Metal itself present in the earth, alkaline in nature. Alkaline means basic in nature. Alkali earth metal we have. Then we have transition metals. Transition from what? Transition from strong metal to non-metal. That's it. The transition metals we have. Then we have other normal metals, aluminium, gallium, tin, lead, etc. Other metals. Then we have non-metals here: carbon, nitrogen, oxygen, phosphorus, sulfur. These are non-metals. These are non-metals. Okay. Between the metals, these are all metals, right? Till this, all are what? Metals. alkali metal, alkali earth metal, transition metal, other metal. All are metals. Maybe some person coming to Christian Mela, I think. From today itself, it started, right? Christian Mela. Between metals and pink color non-metals, we have elements, the grayish color. These are called as metalloids. Metalloids. Based on the property of electrical conductivity, they can be called as semiconductors. Semiconductor, not a good conductor, neither a poor conductor. In between conductivity is seen, right? Example of a semiconductor, Bangalore is called as which city? Which city, Bangalore? Silicon City. Because IT industry based on silicon microchips, right? Silicon is semiconductor. Silicon, germanium, arsenic, boron, antimony, tellurium, polonium, etc. These 6 elements are called as metalloids. 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 Between metal and non-metal, we have elements called metalloids. They will not exhibit the property of metal and non-metal. In between property they have. Based on the conductivity, we can call them as semiconductors. Semiconductor metalloids. Then see here in the 17th group, blue color. 17th group, blue color. They are called as halogens. 17th group, halogens. Hal means salt. Gen means produce. They produce salts, that's all. Sodium chloride, salt. Chlorine. Hydrogen fluoride, salt. Fluorine. Potassium iodide, salt. Iodine. Likewise. Silver bromide, bromine, etc. These are salts. Salt producing chemicals, halogens. Then we have 18th group, very important. 18th group, inert gas or noble gas. Noble gas. Inert gas or noble gas? Why inert gas? The gases present in that group are colorless, odorless, and non-reactive. Colorless, odorless, and non-reactive gases. Helium, neon, argon, krypton, xenon, radon, oganesson, these are non-reactive gases. The reason why they are non-reactive because the outer orbit free electrons are there, right? They have formed bond between themselves. Bond between themselves. Covalent bond they have created. That's why they are non-reactive. If the free electrons are there to create a bond with other elements, then they will be chemically active. If I have 2 electrons, you want 2 electrons, donor and acceptor can create a bond, but they have created bond themselves, not ready to create bond with any other elements. That's why they are called as inert gases, noble gases, self-sufficient. They are non-reactive. Okay, non-reactive. Inert gas. Who maintains the periodic table? Periodic table, addition of new element, etc. It is maintained by an organization called IUPAC, International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry, IUPAC maintains the periodic table. IUPAC, International Union of Pure and Applied Chemistry. Mendeleev discovered the periodic table. Then modern periodic table by Henry Moseley. Henry Moseley, father of modern periodic table. Moseley. One more important thing: electronegativity. Metals are generally electropositive elements. Electropositive elements means they have more number of electrons to donate. Metals can donate electrons. Electronegative elements are generally non-metals. Metals are electropositive elements. Non-metals are electronegative elements. Electronegative means they can accept, ready to accept electrons. Generally, a person who is donating, a person who is accepting, who will be more active, the donor or the acceptor? A person is giving out some prasada food. He's standing at a place. The acceptor will come from various places to accept, right? Who will be more active? Acceptor. Acceptor will be more active. See, in the periodic table, if we go from left to right, electronegativity will increase. Electronegativity will increase. If we go from top to bottom, electronegativity will decrease. Most electronegative element in the periodic table, 18th group elements are non-reactive, right? Inert gas. That's why we cannot consider the 18th group element, except 18th group element. Right side, top corner, we have F. F means fluorine. Most electronegative element, fluorine. The symbol F, most electronegative element. Then the least electronegative element is, actually should be francium Fr, but francium is available in very less quantity in the earth. That's why we are not considering francium, we are considering the element above it, Cs. Cesium, least electronegative element. Cesium. Most electronegative element, fluorine. Donor acceptor, who is more active? Acceptor is more active, right? That's why, which element in the periodic table is chemically more active means, which element in the periodic table which is chemically more active means, that is fluorine. Most electronegative element which is chemically more active. It is chemically more active, right? The 17th group, fluorine, chlorine, bromine, iodine. See, fluorine, chlorine, bromine, iodine, these elements chemically more active. In the nature, they are not available in their free form. They are not available in their free form. Always they will be formed compounds with other elements, because they are more active. More active means ready to form bond with anybody, any other compounds available. That's why they are available in compound form, not available in the free form. 17th group we have halogens. 18th group we have inert gases. Inert gases or noble gases, both are one and the same. Non-reactive, colorless, odorless, non-reactive. Take a break. We'll discuss important elements and then we'll move on to the next topic. Break for 5 minutes. Most electronegative element is fluorine. Least electronegative element? Huh? Cesium. Okay, cesium, CS. Cesium, least electronegative element. Lanthanium is the first element of this group. They are called as lanthanoids. Actinium is the first elements. They are called as actinoids. Lanthanoids and actinoids. Generally radioactive elements. Actinoids. Here, see, the first group, 1A group, lithium, sodium, potassium, rubidium, cesium, francium. If you go from top to bottom, electronegativity will increase or decrease? Decrease, right? Here, fluorine, chlorine, bromine, iodine. If you go from top to bottom, electronegativity will see. In the periodic table, top to bottom it is decreasing. There also it will decrease because the most electronegative element is fluorine, right? Top, most electronegative. Below, little bit less, little bit less. From top to bottom it will decrease, right? Okay. Here, the 18th group, helium. Generally, lightest element in the periodic table is which one? Lightest element in the periodic table. Lightest means lighter, less dense, hagura ಆಗಿರೋದು. Hydrogen. Mass number of helium is more compared to hydrogen, just one mass number. Lightest element, hydrogen. Lightest element. Heavier is uranium 238, mass number more. Heavier, heaviest. More mass number. Second lightest is helium. Second lightest, helium. The balloon, it's generally filled with helium, not hydrogen. Why? Lightest element, hydrogen should have been filled, right? But helium is filled in the balloons, not hydrogen. The reason is hydrogen is a fuel. Hydrogen is a fuel. It will burn. It will cause explosion. That's why it is avoided. Helium is non-reactive. Noble gas, right? Inert gas, right? Non-reactive, colorless, odorless. That's why helium is filled. Helium. Then neon in sign bulbs, in some restaurant, etc. The name of the restaurant will be written in glowy tubes. The tube will glow, right? The letter shaped tube. It is filled with neon. Sign bulb, we say, neon sign bulbs, neon sign boards, neon. Then our atmosphere, Earth atmosphere, Earth atmosphere consists of which gas majorly? The air around us is majorly 78% of nitrogen, 21% of oxygen, 0.03% of carbon dioxide. These gases are there. In the majority, nitrogen is there. Second highest is oxygen. Okay. Most abundant inert gas is argon. In our atmosphere, most abundant inert gas is argon. 0.93 percentage argon is present. How much? 0.93 percentage argon. 0.93 percentage argon is present. Argon, inert gas, non-reactive, colorless, odorless, majorly filled in the bulb. Argon filled in the electric bulb. The filament type bulb, the filament is made up of tungsten because it requires high melting point. The melting point of tungsten is 3422 degrees Celsius. 3422 degrees Celsius. That's why to avoid corrosion of tungsten, to avoid oxidation of tungsten, argon is filled there. Argon. Then we have krypton, xenon, radon, xenon, radon. Radon is called as stranger gas. Stranger gas. Because the name means stranger in Latin. That's why stranger gas, radon. When earthquake happens, the gas released from underneath, that gas released is radon during the time of earthquake. Then in Bangalore, many homes don't have proper ventilation, right? Due to compactly constructed buildings, proper ventilation will not be there. No light, no air. In that case, when a room which is not having proper air and sunlight, proper ventilation, the room will be filled with radon. It will cause lung cancer, radon progeny. That's called radon progeny. Lung cancer will happen. In an examination, they have asked a room with no proper ventilation will be filled with a inert gas called radon that will cause lung cancer. Lung cancer, radon. Then 118th element is oganesson. 118th element is oganesson, Og. In the periodic table, we have 118 elements, right? Among these, 92 are natural. Remaining are man-made. Man-made elements, synthetic elements. The first man-made element among the 118 elements, 92 are natural elements. Then remaining are man-made elements. Okay. Heaviest metal, osmium. Lightest metal, lithium. Lightest metal, lithium. Heaviest metal is osmium. Periodic table is maintained by whom? IUPAC, International Union of Pure and Applied Chemistry. IUPAC maintains the periodic table. Right. Mixtures are classified into majorly two types: homogeneous, heterogeneous. Homogeneous mixture example, homogeneous mixture. Let me give some options. Classify them as either homogeneous or heterogeneous. Okay. Water plus salt solution. Salt completely dissolved in water, whether it is homogeneous or heterogeneous. Water dissolved in salt. Sorry, salt dissolved in water. Hmm? Next, air around us. Air around us. It consists of nitrogen, oxygen, carbon dioxide, argon, etc. Right? It is homogeneous or heterogeneous. Next example, gold. The gold which you are having will be consisting of gold plus copper. Purest form of gold. Purest form of gold is the first man-made element is technetium. Purest form of gold. Have you seen the movie KGF? In that movie, by mining, they extract gold. In the part one, when he was in the first part, before interval, he was in Bombay. There he thought where these gold bars are coming from, right? Then later he got to know there is a place called KGF where they are extracting gold. Then he went there to capture KGF, right? The gold bar biscuit, we say. That is the purest form of gold. That gold biscuit cannot be converted into intricate shapes of an ornament, ring, chain, etc. because it is soft when compared to the ornament gold. Purest form of gold is 24 karat gold. 24 karat gold. 24 karat gold means 99.95 percentage gold. 99.95 percentage gold. Generally in the newspaper, etc., they will give the gold price, right? Today's gold price. That will be 24 karat gold they will be giving. 24 karat gold. The ornament gold, which generally we purchase, is little hard compared to the soft, purest form of gold. That is how much carat? How much carat gold do you purchase? 22 karat gold. 22 karat gold. Ornament gold. 22 karat gold. What will you check when you purchase gold? What will you check? 916 hallmark you check, right? 916 hallmark. 22 karat gold means 91.67 percentage gold. That is the reason 916 hallmark. 916 means 91.67 percentage gold will be there. The remaining percentage copper will be there. Copper, zinc, silver, other metals can be used. Generally in India, copper is used. Copper. Why copper? To give hardness. To give hardness. That is 22 karat gold. See, if you purchase raw, fat, thick, pure milk, it is costly. If some water is added, it is less costly, right? It is impure, right? Likewise, the purest form of gold, 99.95 percentage gold. If the percentage of gold reduces, the rate will also reduce. 24 karat gold rate will be more compared to 22 karat gold. Likewise, if there is a jewelry shop known to your one of your friends who is giving gold at lesser rate, what might be the case there? Percentage of gold will be less, right? Percentage of gold will be less. That might be 18 karat gold. 18 karat gold means 75 percentage gold only. BIS hallmark is there, right? BIS hallmark, Indian hallmark. The hallmark is there for many carats of gold. Even 9K, 9 karat gold gets hallmark. Then 18 karat gold gets hallmark. 22 gets hallmark. Not just seeing the hallmark is okay. You should see whether it is 916 hallmark. 916 means 91.67 percentage gold will be there. 916. That's very important. Hallmark, right? Then if you are purchasing more quantity of gold, you should get authorized hallmark card. Digital card they will give. Physical card, hallmark card with the hallmark authorization by the BIS, etc. It should be given. Gold is naturally, generally, what? Soft. Gold is soft. Now tell me, this ornament gold, is this homogeneous mixture or heterogeneous mixture? Symbol of gold? A. Ag is silver, argentum. Au is gold, aurum. Au gold. Au plus copper is added, right? Gold plus copper. Homogeneous or heterogeneous? You participated in local Olympics. You got bronze medal. Bronze. Bronze means copper plus tin. Copper plus tin. Bronze. It is homogeneous or heterogeneous? Brass, copper plus zinc. Homogeneous or heterogeneous? See, what we really think, what you are thinking, heterogeneous means different things are mixing together, right? That's what you are thinking. Nitrogen separate element, oxygen separate, they're mixing together. That's why heterogeneous. That's what you are thinking. But homogeneous mixture means in one substance, in one material, in one element, other substance is mixing. For example, in water, sugar. In water, salt is mixing. The mixture should be uniform. The mixture should be uniform. You cannot differentiate the mixture substances, the mixed substances by naked eyes nor by microscope. With the help of naked eyes also, with the help of microscope also, if you cannot differentiate, then those mixtures are called as homogeneous mixture. For example, the air around us, can you differentiate? Nitrogen is here, oxygen is here. No, right? Even with the help of microscope, we cannot differentiate. The air around us is homogeneous mixture. Homogeneous mixture. Homogeneous mixture. Uniformly mixed. Uniform mixture. Example. Homogeneous mixture example. Air around us. Then sugar solution, sugar water solution, salt water solution, then 22 karat gold, then bronze. Simply alloys, we can say alloys. These are all homogeneous mixtures. We cannot differentiate neither with our eyes nor with the microscope. We cannot differentiate. Homogeneous mixture. Heterogeneous mixture means heterogeneous mixture. Particles are not uniformly mixed, they are suspended. Just with the help of our naked eyes, we can differentiate them. Just with the help of naked eyes, we can differentiate. If there is so much dust in the air, we can differentiate, right? The dust particles and the normal air, we can differentiate. That is heterogeneous. Water filled with sawdust, water filled with soil, we can differentiate. The dust particles, the soil particles are the sawdust. That is heterogeneous. Salt mixed with the copper sulfate. Copper sulfate is blue in color. Normal table salt is white in color. We can differentiate. That is heterogeneous mixture. Rice with stone. we can differentiate. That is heterogeneous. If we can differentiate with our naked eye, those are called as heterogeneous. Example for heterogeneous mixture are water with oil, water with soil, water with sawdust. Hmm? Oil floats on the surface of water, right? We can differentiate heterogeneous mixture. Water, soil, we can differentiate. Water, sawdust, we can differentiate. These are all heterogeneous mixture. Heterogeneous, we can easily differentiate. Heterogeneous mixture. This is the broad classification, homogeneous, heterogeneous. There is a subclassification. Right. Homogeneous, uniformly mixed throughout, we cannot differentiate. Heterogeneous, we can differentiate, right? These are classified as solution, solution, suspension, then colloidal solution, colloidal solution, colloidal solution, solution, suspension, then colloid. Colloid. Colloid is the concept which we should know. For us to know that concept, we should be knowing these two. Solution means, do you know which element or which substance is called as the universal solvent? Which substance? Universal solvent. Water. Water is called as universal solvent because it has the ability to dissolve many substances in it. Many substances can be dissolved in water. That soluble ability is there, right? That's why it is called as universal solvent, water. It can dissolve many substances in it. In the solution, we have solute plus solvent, that is equals to solution. The dissolving substance salt called as solute. The substance which is helping that substance to be dissolved in it, water, solvent. Together we will get salt solution, salt solution, salt solution. This is homogeneous or heterogeneous? Salt solution, homogeneous or heterogeneous? Homogeneous, right? Solution is homogeneous, homogeneous, homogeneous solution. Then we have suspension. Then we have suspension. Suspended particles means the floating on the surface, suspended freely, right? Suspended particles, not suspended from job. That is different. Suspended particles floating freely. Dust particles suspended in air, we can differentiate. The road beside the institute, it is not having any tarmac, mud road. If a big bus goes faster, dust will come, right? We can differentiate the dust particles. After some time, dust particles will settle down, right? If you have Water mixed with soil, stir it. You can differentiate soil particles and water. After some time, it will settle down. Silt will be formed, right? Suspended particles will settle down. Suspension. We can differentiate the particles mixed in the main substance, right? These are homogeneous or heterogeneous. Suspension. Heterogeneous. That's it. Suspension. Heterogeneous. Suspension. Example, water plus sawdust or water plus soil. Suspension. Sawdust is lighter, it will be floating on the surface. If it is soil, it will come and settle in the bottom. If it is heavier, comes and settles in the bottom. Colloidal solution. Colloidal solution. When we observe through our naked eyes, when we observe through our naked eyes, it feels like it is a homogeneous mixture. With the naked eyes, it feels like it is a homogeneous mixture. But when we observe microscopically, with the help of microscope, if we observe, actually it is a heterogeneous mixture. The villain in the movie, in the first half, Kalavati, na name? What is the name of the heroine in Kantara? Kanakavati. In the first half, she was a good woman, good lady. Later we got to know she's the villain, right? Likewise, it feels like a homogeneous mixture, but it is not. Colloidal solution for naked eye, it feels like it is homogeneous, but actually it is heterogeneous. If they ask colloidal solution homogeneous or heterogeneous, means heterogeneous only. Heterogeneous only. Homogeneous, not heterogeneous. When we observe microscopically, then only we can know that this colloidal solution is heterogeneous. Example for colloidal solution: cloud, mist, fog. See, or milk and milk plus water, etc. Many are there. See, when you see the milk, the normal milk, fresh milk, can you differentiate any suspended particle in the normal milk? With the naked eye, you cannot. When you heat the milk and when you cool down the milk, what will happen? Layer of fat will be floating on the surface, right? Cream, it will be floating on the surface. Where it was earlier, it was suspended freely throughout the milk. The fat molecules were suspended throughout freely in the milk. That is heterogeneous milk with fat, heterogeneous mixture. That is a colloid. Then water mixed with milk. For our naked eye, it seems like it is a homogeneous mixture. But when we observe microscopically, it is heterogeneous mixture. The base material and the added material will be suspended freely. Heterogeneous mixture. The air around us, if you see, it feels like homogeneous, the normal air. But it will be having some sort of dust, right? Here the area is little bit peaceful, less movement of vehicles. That's why less dust. In the busy area, dust will be more. Minute dust particles, which we cannot see with our eyes. If you switch on a torch, you can observe small dust particles, right? If you switch on flash, you can observe the small dust particles. Those dust particles present in the air will be continuously floating in the air. That is colloidal solution. That is colloidal solution. Then fog mist means in the air, small water droplets are floating, right? That is fog. Small, minute water particles. That is colloidal solution. Cloud. How cloud is made? Water on the surface of the earth evaporated. The small water droplets combine to form cloud. Small water droplets. Cloud is made up of small Small water particles. When condensation happens, it starts to rain. When condensation happens, it starts to rain. Cloud, mist, fog, etc. are the examples of colloidal solution. For our naked eye, it seems as homogeneous, but actually it is heterogeneous mixture. When light is passed through this colloidal solution, when light is passed through this colloidal solution, the scattering of light happens. Imagine you are traveling early in the morning, 6, 7 a.m., not so early, in the morning, in a hill station filled with fog, filled with mist. You are using, the visibility is low. You are using your projector light, your fog light you are using. The beam of light coming from your car, it will be seen little differently, right? You can see the beam coming out from the light. When you are sitting in the film theater, the beam of light coming from the projector, the small dust particles can be seen, right? Film theater, projector, beam of light. When you are in a forest, from the canopy of the trees, the light rays are coming, right? Light rays from the gap, the canopy. And an old house, from the clay tiles, a ray of light coming in. That is, that effect is called as Tyndall effect. Tyndall effect means scattering of light when it is passed through colloidal solution. When light passes through colloidal solution, scattering happens. That scattering is called as Tyndall effect. Tyndall effect. The scattering of light. The scattering of light. See, from the canopy. From the canopy, the rays are coming. Tyndall effect. Then for any heterogeneous mixture also we can observe in the film theater, etc. And from the window gap, the beam of light coming in, Tyndall effect. Tyndall effect. Tyndall effect is means scattering of light when it is being passed through colloidal solution. That's it. Scattering of light happening when it is being traveled through colloidal solution. Tyndall effect. Tyndall effect. Then in the colloidal solution, the suspended particles, which we cannot see, we can see through microscope, right? The suspended particles in the colloidal solution. Those particles move in zigzag shape. Those particles move in zigzag shape. That is called as Brownian moment. Brownian moment. The colloidal particles move in the zigzag shape. That is Brownian moment. The moment of the suspended particles in zigzag shape. Brownian moment. Robert Brown, botanist, discovered this, the Brownian moment. Okay, now alloys are homogeneous or heterogeneous? Alloy. Alloy means two or more metals combined to form a new material. For example, brass, bronze, 22 karat gold, etc. They are homogeneous mixture. Alloys are homogeneous mixture. Heterogeneous mixture example, water with oil, water with sawdust, etc. Heterogeneous mixture. Colloidal solution example, cloud, fog, mist, milk, etc. These are the examples, right? Okay. Metals and non-metals. Metals and non-metals. Which is a good conductor of electricity? Metals are good conductors, good conductors of electricity, Why? Why? Because they have free electrons. They have free electrons to carry charge. To carry charge, they require free electrons. Metals are good conductors. Non-metals are bad conductors. Bad conductors. Except what? Except graphite. Graphite is an allotrope of carbon. Graphite is an allotrope of carbon. Allotrope means made up of carbon only, but the structure is different. Diamond is also made up of carbon. Graphite is made up of carbon. Normal carbon made up of coal, carbon itself, but the structure is different. Those are called as allotropes. Allotrope of carbon. Then melting point, where it is high, where it is low. Melting point. Which one will be having more melting point? Metals. More melting point and boiling point. These have less melting point and boiling point. Which are electropositive, which are electronegative? Metal electropositive, they can donate electrons. These are electronegative, they can receive electrons, electronegative. If I tap plastic above, no proper sound, but metal on the metal, then this is hollow. On metal, it will give some sound, right? Metals have sonorous property. Sonorous means they can produce sound. Sonorous metals. Non-metals are not. Then very important property, ductility and malleability. Ductility, malleability. Ductile means which can be converted into thin wire. Thin wire. They are more ductile, they are less ductile. They are not ductile, non-metals. Ductile means by applying load, this can be converted into very thin wire. Very thin wire. That is ductility. Ductility. Okay. Most ductile metal, gold. Most ductile metal. Then malleability. By applying load, it can be converted into thin sheet. This too, this thin sheet. Most malleable metal is gold. Very thin sheet, it can be converted into thin sheet. Metals are malleable. Metals are ductile. Metals are good conductors of heat. Metals are good conductor of electricity. Metals are sonorous. Metals are electropositive. Right? Density of metals are high compared to non-metals. Density is high. Density means how compactly the particles are packed. Right? More dense metals. Let us know some important symbols of some elements which we use in our day-to-day life. Symbol. How the symbols are given. Symbol of iron, Fe, ferrous, ferrum. One based on their color, one based on their origin, place, then based on their property, etc., various kinds, they have given the name. For example, gold is a yellow metal, right? Gold, yellow metal. That's why the name Aurum. Aurum means yellow. Copper is from the Cyprus region in the Middle East. That's why the name cuprum. That's why. Based on the place of origin or based on their color properties, they have given the name. Majorly from Latin, Greek, etc. languages. Okay. Symbol of iron, Fe. Symbol of gold, Aurum, Au. Symbol of silver, symbol of silicon, silver argentum Ag, silicon Si. Symbol of mercury, hydrargyrum Hg, Hg, mercury, Hg, mercury. See, average human blood pressure is average human blood pressure BP 120/80 mm of Hg. Mm of Hg means the old BP machine you might have seen. They used to pump. There is a liquid which goes up and down, right? The liquid is mercury. Millimeter of mercury. How many millimeter it goes up? How many millimeters? That's what. Mm of Hg. The unit of measuring our BP. Millimeter of mercury. Right now we are using digital meters. Then also the unit is same. 180/80 millimeter of mercury. Mercury symbol Hg. Aluminium, copper, zinc, sulfur, magnesium, manganese, lead. Lead is poisonous. Lead, plumbum, Pb, tin. Our electrical fuse. Electrical fuse is the right. The melting point of fuse should be more or less. Electrical fuse's melting point, should it be low or high? You have fuse at your home. It is a safety device, circuit breaker, right? Its melting point should be more or less. It should be less, it should melt. Otherwise, what will happen? Hey, what a super quality fuse. It is still intact. My TV is blown out. What is the use, right? It should be low melting point, having low melting point. When the over current comes, more amount of current comes, the temperature will increase, then fuse will melt. Blow out, it will melt, right? Lead and tin alloy is used there in the fuse. Lead and tin alloy. Tin symbol Sn, tin, Sn. Nickel, nickel, Ni. Phosphorus, potassium, potassium K, phosphorus P. Any other metal you want to know? Okay, I hope these are the materials which we will be using in our day-to-day life. Copper, nickel, zinc, silicon, sulfur, magnesium, manganese, lead, tin, mercury, tungsten. Tungsten in the filament type of bulb, the bulb we use tungsten, right? Its symbol is W, wolfram W, tungsten symbol. Tungsten, W. Okay. What is the purest form of iron? Iron. Purest form of iron. Options they have given: cast iron, pig iron. It is their pig iron. Wrought iron, steel, stainless steel. Purest form of iron. Actually, iron normally is little soft. Soft is nothing but spongy. Compared to steel, compared to cast iron, it is little bit soft. The purest form of iron, it is wrought iron. Wrought iron. Generally, iron Fe is mixed with carbon. Iron mixed with carbon. Carbon gives hardness to iron. The hardness of the iron is due to the carbon present. In wrought iron, the carbon content is less than 0.25 percentage. Less than 0.25 percentage carbon is there. Wrought iron. In Kannada, wrought iron, Madhu Kabbina, Madhu, soft iron, wrought iron. Carbon content less than 0.25 percentage. In stainless steel SS, the carbon content will be 0.2 percentage to 2.1 percentage. In this range, the carbon content will be more than 2.1 percentage means it will become brittle. Brittle means if you drop, it will break. That sort of material it will happen. If carbon content increases, brittle nature will come. How alloys are made? Alloy. By melting the base metal and adding the other required metal, both in molten state, alloy can be formed. Example of alloys: 22 karat gold, gold plus copper, bronze, brass, German silver, gunmetal, etc. etc. So many types of alloys are there, right? Alloys. Homogeneous or heterogeneous alloys? Homogeneous mixture. Copper plus zinc is an alloy of brass. Copper plus tin, bronze. Copper, nickel, zinc. German silver. Copper, tin and zinc. Gunmetal. Iron, chromium, nickel, stainless steel, etc. There are so many alloys. See, have you heard the name German silver? During the time of Varamahalakshmi festival, there was so many silver-like duplicate white metal ornaments, right? Silver-like, those are not silver, duplicate, silver kind of. That is German silver. German silver does not have silver itself. The name says silver because it looks like silver. It is an alloy of copper. Alloy of copper, German silver. Looks similar to silver, that's it. alloy of silver. One important thing, if two or more metals combine together to form, that is called as alloy, right? Alloy. Mercury, is it a metal or non-metal? Mercury. Is mercury a metal or non-metal? Mercury is a metal in liquid form. Only metal in liquid form. All other metals are in solid form, right? Mercury, Hg. Mercury. If a metal forms alloy with mercury, if a metal forms alloy with mercury, it is called as amalgam. Amalgam. Amalgam means alloy with mercury. Amalgam. Any metal forming alloy mixture with mercury, that is called as amalgam. Amalgam. Very important thing. These four metals cannot form amalgam with mercury. These cannot form amalgam with mercury. Who? What metals? Iron, tungsten, platinum, tantalum. Iron, tungsten, platinum, tantalum. Only these four elements cannot form amalgam with, can't form amalgam with mercury. In many examinations, they have given the statement telling that whether iron can form amalgam with mercury. Whether it can form? No, it cannot form amalgam with mercury. What happens if you place iron piece into a bowl containing mercury? If you place iron piece into a container with mercury, this is filled with mercury, Hg. If you place a iron piece into it, whether it will sink or it will float or it will mix, they have asked. When compared to the density of mercury and iron, the density of iron is around 8 to 9.5 gram per centimeter cube, around 9 gram per centimeter cube. Density of mercury is 13.535 gram per centimeter cube, which is having more density, mercury. Mercury is more denser. More denser means less denser particle will float on the surface, right? If you place iron into mercury, the iron will float in the surface of the mercury. The iron will, what happen? It will float. Iron will float. It will not mix with mercury. It will not form amalgam with mercury. Very important. Can silver form amalgam with mercury? Yes, other than these four elements, all other elements can form, all other metals can form amalgam with mercury. Amalgam means alloy of mercury, that's it. Alloy with mercury, that's all. Okay, fine. We'll continue on Monday's class. Will you come?